Hello guys, let's welcome to our channel Just Genius. In the last video we have completed big omega notation. In this video we are going to start big theta notation. So before going to this notation you can watch any big O notation and big omega notation. So similarly this notation also same, but the inequality changes. Okay, so let us start our video now. So when you look into this big theta notation, or you can call it is a theta notation. Okay, just we call theta notation. So the symbol of this theta notation is this one. So you know theta, this is theta. Okay, so first going to discuss about theta notation, we have to know definition of the theta notation and when to use and why to use this theta notation. Okay, along with this we will discuss graph of this theta notation also. So when you look into this, when you look into the definition of this theta notation, we express tighter bonds. Tight bonds are nothing but average bonds. Okay, average bonds. So theta notation is mainly used to express in average bond, where big O notation is used to use in upper bonds, big omega in lower bonds, theta in average bonds. Okay, f of n equal to theta of g of n means f of n equal to big O of g of n and big omega of g of n means it states that so f of n equal to theta of g of n. To be satisfied this condition, the f of n must be big O of g of n and big omega of g of n, means it is both upper and lower bound condition, that is nothing but average bound. Okay, I hope that you have understood. To satisfy this condition we have to satisfy these two conditions, because it is an average bond, that is means upper and lower bond, that is nothing but the mode mix means that it comes, we can note that is tighter bond, that is an average bond. Okay, so condition is given here. I will write here C1. So here two constants will be there, C1 and C2. C1 less than or equal to f of n, means f of n lies between C1 and C2. It says that from the definition you can understand f of n lies between C2 into g of n and C1 into g of n. So in between these two values f of n values lies. Set of all functions have the same rate of growth as g of n. Okay, g of n is asymptotically tight for f of n. Okay, this is the major definition of this big theta notation. So we can write like for all n greater than or equal to n naught, for all when this condition C1 into g of n less than or equal to f of n less than or equal to C2 into g of n for all n greater than n naught. Okay, so if you want the definition I will write once again here. So if you want the definition, similarly you have to take two positive functions. Let f of n comma g of n be two non-negative, I will write quickly, understand, I will two non-negative functions and f of n equals to theta of g of n if there exist three positive constants, that is C1, C2, comma n naught, C1, C2, n naught, such that C1 into g of n less than or equal to f of n less than or equal to C2 into g of n. Okay, for all n greater than or equal to n naught. This is the definition of this theta function, big theta function. Okay, so we can understand this definition. So you can look into this definition once again. So look into this once again definition, you can understand it easily. This is easy definition. Remember this point, three constants are used, this condition. So it is both upper bound and lower bound. Okay, that is nothing but an average bound. So it provides lower bound and upper bound on growth rate of algorithms, running time and space time. Okay, space uses. So we have completed definition. Now we will look into the graph of this one. So this is the graph of this big theta notation. When you observe this graph, f of n lies between C2 into g of n and C1 into g of n after this n naught point only. So before this n naught you can draw the conditions. Okay, so this condition gets true. So if you observe this graph carefully, you can observe that C into g of n, f of n, C1 into g of n. Okay, f of n equals to theta of g of n. So you can write like this also, you can write like this also, theta. Okay, it's no issue. For all n greater than or equal to n naught, for all n greater than or equal to n naught. So this condition gets true. With this we have completed big theta notation. In the next video we will solve one problem related to big theta notation. The each and every material of the data structures can be uploaded in, means the nodes of data structures and algorithms are uploaded in description box. You can access the drive link from the description box. If you like this video, please like, share and subscribe. Also, I have mentioned a Google form in the description box. If you please, I request you to submit. It takes less than 30 seconds. Please, I request you to fill that form. Thank you.